Hello everyone. Today we are going to discuss the main topic emission and absorption of radiation. So, so oh, one second. So before in the first class of time dependent perturbation theory, I have told that if we want to if we want if we want to allow the transition between one energy level to the another energy level, we must introduce the time dependent potential. Okay, so if we want to allow the transition from one energy level to another level, we have to introduce the one time dependent potentials. That's the quantum dynamics. So there are preciously very exactly the soluble problems in the quantum mechanics. So emission or absorption of radiation are important applications to the time dependent perturbation theory. Okay, so today we are going to discuss about time dependent potentials. Okay, means not time dependent potentials. First we are going to learn emission and absorption of radiation. Okay, so an electromagnetic wave, so means electromagnetic wave means there is electric field and magnetic field to that wave, so which are the electric field vectors and the magnetic field vectors in electromagnetic wave. In electromagnetic wave, electric field vectors and the magnetic field vectors are mutually perpendicular to each other. Okay, the electromagnetic waves are transverse waves. Transverse waves means the vibration of vectors, means vibration of the electric field or magnetic field which is perpendicular to the propagation of a wave. So wave ఒక some x direction లో వెళ్తుంది అనుకోండి, వేవ్ అన్నది ఒక x direction లో వెళ్తుంది. సో x direction లో వెళ్తున్నప్పుడు propagation of wave is in the x direction. So these electric field and magnetic field are perpendicular to the motion propagation of a wave ki perpendicular ga unte kanuka then we call it as transverse waves. So electromagnetic waves are the transverse waves. Okay, so here is written consist of a transverse waves. So here is written, okay, an electromagnetic wave, I will refer it as a light. So electromagnetic light is an electromagnetic wave. So though it could be infrared, ultraviolet, microwave or x-rays, anything. So okay, ఇప్పుడు ఈ infrared, ultraviolet, microwaves and x-rays all only differ in the frequencies only. Okay, so consist of a transverse means mutually perpendicular oscillating electric field and magnetic field as shown in the figure. So here this is the transverse wave. This is the electromagnetic wave is in transverse wave because electric field is in the y direction, but electric field and magnetic field is oscillating perpendicular to the direction of the propagation of a wave of a electromagnetic wave. Then we call it as transverse waves. Okay, an atom in the presence of an passing light wave responds primarily to the electric component. So if the wavelength is long compared to the size of an atom, we will ignore the partial variation in the field. The atom is exposed to the sinusoidal oscillating electric field. So when the atom will vibrate, so we will send the light, but if the wavelength of the electromagnetic wave what we are sending, that radiation, it should be near to the wavelength of an atom, then only the atom will vibrate, means atom will excite. ఇప్పుడు యాటమ్ అనేది ఎప్పుడు ఎక్సైట్ అవుతుంది అంటే యాటమ్ యొక్క స్పెసిఫిక్ వేవ్ లెంత్ ఉంటుంది. సో ఆ వేవ్ లెంత్కి మనం ఇచ్చే ఎలక్ట్రోమాగ్నెటిక్ వేవ్ అన్నది ఇట్ షుడ్ బి మ్యాచ్ అవ్వాలన్నమాట. మీన్స్ నియర్లీ ఈక్వల్గా ఉన్నా కానీ యాటమ్ విల్ ఎక్సైట్ ఫ్రమ్ ద వన్ స్టేట్ టు ద అనదర్ స్టేట్. సో ఓకే, if the wavelength is more is long compared to the size of an atom, we can ignore this partial variation in the field. Okay, then atom is exposed to sinusoidal electric field. అప్పుడు ఆటమ్ అన్నది సైనసోయిడల్ మామూలుగా జస్ట్ వైబ్రేట్ అవుతుంది, కానీ ఇట్ కెనాట్ ఎక్సైట్ ఫ్రమ్ వన్ స్టేట్ టు ద అనదర్ స్టేట్. If we give the right wavelength to the atom, then only the atom will excite from the one state to the another state. Means go from one state to the another state. Okay, state. For the moment, I will assume. So it is we have given the electric field to the atom, then it is exposed to the sinusoidal electric field. So this electric field is like this. It is along the k direction. For the moment, I will assume that the light is a monochromatic and polarized along the x direction. So what is this monochromatic? Monochromatic means having only the one frequency. So having single frequency. Monochromatic means having only single frequency. There is no different. So light is not a monochromatic light, and it's an unpolarized light. Because if we polarized light means so the vibration of an atom is in one direction only, has one component, one either in x direction or either in y direction. It has only the oscillation is only one direction only, electric field or if it మేము చూస్తే కనుక ఎలక్ట్రిక్ ఫీల్డ్ అన్నది దిస్ ఎలక్ట్రిక్ ఫీల్డ్ is a polarized light, ఎందుకంటే it has the polarization along the x direction only. Okay, so electric field is oscillating only in the x direction. If it is means k direction, means z axis. So if it is oscillate in the k direction, x direction, y direction, then we call it as a unpolarized light. Remember. Okay, so monochromatic light means